Okay, so let's start. In the last class, we have seen how to use the Capsturn software, okay, to generate the program automatically for the given diagram. Okay, and yes, okay, I will take up this particular problem, that is problem number 5. Okay, just a second. Yes, so we will see for problem number 5, which for the same diagram we have written the program using CNC software. For this diagram, if you look at this, we have to do facing, plane turning, then finish turning, then grooving, and then threading, and also finally drilling also has to be done, right? So all these operations has to be carried out. So for this, yeah, the coordinates are here, as we had discussed when we did the same problem for manually writing the program. Okay. Okay. Right. So now, okay. So now let us see how to do this problem using Capsturn software. Okay. Right. Okay. So first we'll go to Capsturn software, but before this, for any, let it be CNC turning, milling, or Capsturn or Caps mill, first write the coordinates in the table, yes, so that it's going to become easier. Yeah. Right. All right. So yes. So let's continue with the class. Okay. So create a new part. Okay. Then on this particular window, we'll select the units to be workpiece, material. So as no materials are defined, we'll take it as aluminum only. Okay. And then we'll go for, or you can use mild steel or stainless steel. Okay. Yes. Now jaw position, that is at what coordinate of z the jaw should be there. Of course, the jaw is not going to move, but it's going to keep the uh, x and z axis to be at a particular distance from the jaw. Okay. So outer clearance, here from the diagram we need about maximum is 45. Okay, so we'll first draw the part. Yes, go to the multi-line option. Okay, so we'll get this particular window over here. Enter the x and z coordinates. First 0, 0, right? So yes, we'll draw a line for vertically, the above direction. Then diameter is going to be 7.5, and for the next coordinate 30, right? That is diameter is 7.5. Sorry, the radius, because we are drawing only one half of it, and later on in the subsequent steps we can mirror it. So here next we have actually a grooving, so the diameter will be lesser, so x value will be less than 7.5. So you can also choose the groove width over here directly, and what type of shape, I mean how the groove should appear, external or internal, right facing or left facing, all other details. Otherwise, we can draw it only with straight lines. It is not a problem. We can use multi-line or line option, and we can give the coordinates. Okay. So depth is going to be 2.5 for the given thing, from 7.5 minus 2.5, right? And width, yes, we'll give that, and you can join it at the end of the line. Otherwise, we have to draw 3 lines. Okay. So let it meet exactly at the end of the line. Continue with the coordinates after finishing the groove. Seven point five minus 60, and 12.5 minus So here we can go for radius or draw the radius. So just look here, what has been shown over here is that -7.5 minus 40. Okay, so it starts at this particular place where we want to draw an arc. So over here, this particular thing over here, yeah, just a second. Right, now we want actually to draw this particular arc. Here, this portion. Okay, now and here we have the other manner, right? Okay, so after this, and we go for the arc. Okay, I'll just show you here. Here, arc, start, end, and radius. So we are going to use the arc command. We have to give the starting point coordinate, ending point coordinate, and the radius. Okay, these three things should be known. But when it comes to this radius can be drawn. Now when I take up this radius says for example R10. Okay. Now when I give, this is the starting point, this is the ending point. Fine. And radius also we are going to enter. Now how does the computer assume whether the arc should be like a C shape like this or it should be the other way around? Okay, still the starting and ending point coordinates are same. Okay, so for that there's a different way how to get the arc in the right manner. Okay, now let's see that. So we'll go to arc, start, end, and radius option. So look here, we'll give the starting point of the arc, specify the start point. Okay. Yes, 7.5 minus 60 over here. Okay, and then specify the end point of the arc. This 12.5 comma minus 65. Now look at this, the arc appears to be and then enter the radius. Okay, now if you look at it, it's going to be in a different manner. Okay, we don't want the arc to be like this. So what we'll do, we'll go back. That means now what is happening according to this particular software, when I say for example I'll just use, now when I want the arc to be in this particular manner, okay, this should be starting point and this should be the ending point. So if I'm going to have any part programming from here, right, like this. right? So when I want to have the arc like this, now first I should give this particular point as the starting point of the arc, and then this one. Now when I want the arc to be placed in the inverted C shape the other way around, okay, then I should give this one as point number 1 and here as point number 2. So the arc will appear like this. Okay. So what is actually happening when you specify the starting point and ending point? How does the computer assume always is that it always goes round in the anti-clockwise direction only. Okay, in the anti-clockwise direction. Now when I take this one as point number 1 and this is the end point of the arc, then in the anti-clockwise direction I'll get an arc in this particular manner. Okay, now when I have the same thing, to be like this, and what is the logic? In anti-clockwise direction. So if I'm going to take this as point number 1 and this one as point number 2 in anti-clockwise direction, it is going to go around like this, right? So when I do it up in this particular manner, I will get an arc of this particular manner, okay, in this particular shape. Okay, so please remember this. Okay, right. So that is why now if you look at it, specify the, one second, specify the start points of the arc 12.5 comma minus 65. See here, where is it? The point is here. Okay, not yet connected to the part that we have drawn already. Now this particular point where the end of the line is there, that is going to be the end of the coordinate for the of the arc. Okay, so we'll enter that as the end point of the arc, which is 7.5 comma minus 60, and then the radius. Enter the radius 5. Get it. Yes. Now go as per the drawing. If it's a line or a multi-line, we can choose it. So from here, it's going to be vertically above. Yes, 12.5 minus 65. And then it's going to be vertically above. Sorry, horizontal. 12.5 minus 80. Now we'll be going in for an arc like this. Okay. So arc 12.5 minus 80. End of the arc 32.5 minus 90, and then the radius. So for line or multi-line, give the next coordinate to draw the line. Yes, so save this contour, okay, so that the white lines will be converted into red lines. Now go to defining the blank. Define blank over here. So overall length 35. Diameter of the blank, maximum diameter for the part is 45. Okay, here since we are drawing only one half, okay, give the radius. Select CNC machine. Yes, next go for machining tab. As soon as you click on the machining tab over here at the bottom, you can see the drawing that we have done on only one side has been mirrored onto the other side also. Now we'll go one by one operations. First is facing operation, external turn, shank 16 by 16 mm. Select a point on the blank, okay, to do the facing operation. Okay, so facing tool we have selected. Where should it do the machining? On which particular part, which line? That we have to select carefully. Yes, now give the operation name and other data. Safe approach 2 mm, that is in X and Z axis. At what distance should the tool arrive and be closer to the workpiece before the operation starts. Then finishing allowance, if at all we need, we can give it. So 0.1 finishing allowance if we give, then we have to use the next operation should be finish facing operation. Depth of cut 2 mm and overshoot is that below the horizontal axis, how much should the tool go beyond? Yeah. Yes. So next we'll go to it. If all we need, we can give this overshoot, otherwise no. So instead of doing it 2 times, So we are just showing over here in each step what is going to happen when we enter different values for finishing allowance in X, Z directions or depth of cut or overshoot. Let's go for finish turn, finish phase. And click the extreme right hand side edge of the workpiece. Overshoot we can give because in rough facing also we are given overshoot. Next we can go for contour turn. Okay, so turning will be done from starting from one point to the other point that we mentioned along its path, whether it's straight or vertically upwards or curved manner and so on. Okay. Yes, so we are going to start from one end of the workpiece to the other end of the workpiece. Then you get this window where we'll give the safe approach distance 2,2. Finishing allowance, yes, because it's going to be rough turning operation. We'll give the finishing allowance. Then depth of cut for each pass. That also we can give. For total depth of cut, you can see here that what is the distance vertically measured from the highest diameter to the lowest diameter. -45 minus 15 to be equal to 30 mm divided by 2. That's 15 mm is going to be the total overall distance, the difference in the diameter. Yes. You can see here. Yes. So keep saving the progress that you have made from time to time. Let's now go for the grooving operation. External groove, shank size 12 by 12, width of 2 mm. Ensure the width of the tool and the height, cutting height that the tool can perform. So select only the grooving portion that so external groove, safe approach 2 mm. Okay, finishing allowance. Whether it has to do it in pecking manner, that is for depth of cut for a certain depth, and then return back and then go for the depth of cut once again. So here there are cutting methods also. If you look at that, the cutting methods available. So once when it is in plunge, it is going the tool is going to move in this particular manner. Cutting method we have totally given 4: plunge, deep groove, one way and two way. This is the plunging method. Next, for deep groove method, just look at how it is going to perform. Next, one way, so it is just going to do it like a turning operation only. Right? Two way, so it's going to move from left to right and right to left continuously, removing the material. So we'll generally go with the plunging method. Starting location where the tool should be nearer to the groove, whether it should start grooving from left hand side or right hand side. Next we'll go to threading operation, external thread. Okay, shank size 20 by 20. So threading, safe approach 2 mm, it is away from the workpiece. So once you click on the thread types, okay, you can select the whether it's Acme thread or ISO thread or whatever it is. So we'll go for metric thread. So with respect to the calculation, that is the pitch that has been given. 1.5 is the pitch that is given. So we can That is possible when we select from standards. Okay. Otherwise, we have to give all these data over here. The number of cutting passes we can decide. What is the thread of pitch? What is the thread depth? All these data we can enter manually also. So entry distance is at what distance should this tool uh, start its threading operation where from the workpiece. Okay. At the same time, once the threading is going to be over, to what extent should the threading tool go further beyond? Okay. Yeah. So all the operations have been mentioned. We'll go for the tool path simulation tab to see the simulation. So you can simulate it using line by line or complete up to tool change. Now you can see that the facing operation took place. So one tool at a time that we are choosing. Finish face. And now so you can see here. Yes, so you can see here now the tool is going to do the turning operation. We have given contour turning. Yes, so it is going to do the turning operation from the starting of the workpiece to the end of it. Okay, in a continuous manner. Okay, there is even plane turn, but plane turn we have to select every line separately so that until that particular portion has been machined, the tool will not do the turning operation onto the next portion, whether it's horizontal or vertical line that has been present. Now we have got the grooving operation. With threading. So if we want to add or delete any of the operations, we can go back to the machining tab and remove that particular tool and operation that we have mentioned. So now if we want to change the grooving method, you can go to machining tab and change it. Now let's check that. We'll see how the simulation looks. So in contour turning, the turning tool will move along the path. So this is the plunging method. So yes, the various operations are being shown, options are being shown for each operation that is being present. Right. So you can only simulate the required operation that we need, and we can also check. Okay. Right. Okay. So yeah. So let's see. Let us see this particular problem. That is problem number 2. We have this particular diagram. Okay. And see the video for that, how to do it. Go to Capsturn. Create a new part. Material. You can select a material from the list. Okay. Job position. The diameter of uh, the workpiece. I mean the maximum diameter after machining of the part. So first go for line or multi-line. 0, 0 is the starting point. Then 7.5, 0. And 0.5 minus 30. yes, the next point. One second. No, there is something. Just a second. Hold on, please. Sorry. Yes. So whatever is the length of the workpiece, give that as the job position, absolute 0, and then the maximum diameter of the part. Can go to line or multi-line. Enter the coordinates. So here you can also see just below the place where we enter the coordinates, we have three options. Here, first one is absolute APS, second one is relative coordinate system, third one is polar coordinate system. So we can enter the values by in any of these three methods and select the suitable method also. Yes, here if you see, when you want to draw an arc, we have options for that. 3 points, starts, enter the values like this: starting value, center and end. Okay, then starting, center and angle, then starting, center and chord, right? So we have like this. Yeah, and we also have the other ways also. So we'll go to arcs, to draw an arc, start, end and radius. Five comma 0 and 10 comma minus 5, and enter the radius value. So enter the radius. Then continue with drawing the part. So if you do any mistake, we can erase it by using the erase option and click on that particular line or arc and click on OK. Once you do it, as I just mentioned, we have to carefully see how do we need the arc to be drawn. Yes, after drawing, go to define the contour. So the drawn part line, the diagram has been recognized as a part. Define the blank. Yes, start Z or 2 mm, 1 or 2 mm. I'll go to machining tab. So you can see that the part and the raw material has been mirror imaged. Go for selecting the tool, but before that, the operation should be selected first. Only then the tools will appear. So enter the details for plane facing, safe approach 2,2. Finish facing, external return, 16 by 16 mm shank, PCLNL, PDJNL, and select the line or points from the diagram. So contour turn starting point till the ending point is what we have to select for for contour turning. Yeah. Safe approach distance 2,2. Finishing allowance, since it's a turning operation, give the finishing allowance also 0.5 or 1 mm. So calculate the total depth, maximum dia minus minimum dia by 2. Enter that value over here. Next go for finish turning operation. After this, go to the toolpath tab to see the simulation. Fit the diagram to the screen. So if at all, if the job position is too far away or closer, then we can adjust it by going to the geometry tab once again. See the simulation over here. So contour turn along the for contour turning, the tool will move according to the shape of the part that has been drawn. Okay. Yes, so we'll stop here for today. Okay. These two problems we've seen on Capsturn. Okay, Nancy attendance. Niharika.
Yes, sir.
Okay. Then Nihar.
Yes, sir.
Okay. Nikhil R.
Yes, sir.
Nilesh.
Present, sir.
Okay. Neerab.
Yes, sir.
Prajwal Patel.
Present, sir.
Prajwal, yes, but. Okay. Then Rishabh Pandey. So
Present, sir.
Prince is absent. Okay. Rishabh Pandey present. Okay.
Yes, sir.
Rohan K. Roshan Yadav.
Yes, sir.
Okay. Suman Sagar.
Yes, sir.
Okay. Sagar Dutt Mathur. Okay, absent. Sagar GV.
Present, sir.
Okay. Sanjay Raghav. Sharanaya. Absent. Not there. Sheikh Manan. He is also not there. Shobit. Not there. Siddharth B. Shankar.
Present, sir.
Okay. Siddharth Sridhar. Not there. Subramanya.
Present, sir.
Sumuk. Sumuk is not there. Nirmala Shetty Rohan.